Good day everyone! We are now going to discuss about solving exponential equations and inequalities in general mathematics from Analyze Math. Definition: let a is not equal to 0. We define the following. A to the power of 0 is equal to 1. So this is now the zero exponent property. A to the power of negative n is equal to 1 over a to the power of n. This is the property of negative exponent. Theorem: let r and s be rational numbers. A to the power of r multiplied by a to the power of s is equal to a to the power of r plus s. This is the product property for exponents. A to the power of r over a to the power of s. This is a to the power of r minus s. This is the quotient property for exponents. A to the power of r to the power of s. This is a to the power of rs. This is the power property for exponents. Next, a b to the power of r. This is a to the power of r, b to the power of r. This is the product to a power property for exponents. Lastly, a over b to the power of r. This is a to the power of r over b to the power of r. This is the quotient to a power property for exponents. Which of the following are exponential equations? A. 49 is equal to 7 to the power of x plus 1. B. 7 is equal to 2x plus 3. C. 3 to the power of x is equal to 3 to the power of 2x minus 1. D. 5 to the power of x minus 1 is equal to 125. E. 8x is equal to x squared minus 9. F. X squared is equal to 3x cubed plus 2x minus 1. G. 2x plus 3 is greater than x minus 1. H. 2 to the power of x minus 2 is greater than 8. I will give you 2 minutes to answer. Now, only A, C, and D are exponential equations. Solving exponential equations. Some exponential equations can be solved by using the fact that exponential functions are one-to-one. One-to-one property of exponential functions. If x sub 1 is not equal to x sub 2, then b to the power of x sub 1 is not equal to b to the power of x sub 2. Conversely, b to the power of x sub 1 is equal to b to the power of x sub 2, then x sub 1 is equal to x sub 2. Let's now solve the equation 4 to the power of x minus 1 is equal to 16. So we write both sides with 4 as the base. So 4 to the power of x minus 1 is equal to 16. So 4 to the power of x minus 1 is equal to 4 to the power of 2. So using the one-to-one property of exponential functions, that becomes x minus 1 is equal to 2. Then, by addition property of equality, you add both sides of the equation by 1. So that becomes x is equal to 2 plus 1. So x is equal to 3. Let's now solve the equation 125 to the power of x minus 1 is equal to 25 to the power of x plus 3. So 125 to the power of x minus 1 is equal to 25 to the power of x plus 3. We write both sides with 5 as the base. So that becomes 5 cubed to the power of x minus 1 is equal to 5 squared to the power of x plus 3. By the power property of the exponents, so that becomes 5 to the power of 3 multiplied by x minus 1 is equal to 5 to the power of 2 multiplied by x plus 3. Then, by one-to-one property of the exponential functions, that becomes 3 times x minus 1 is equal to 2 times x plus 3. Using distributive property, we distribute 3 to x and to negative 1. That becomes 3x minus 3. Then we distribute 2 to x plus 3. So that becomes 2x plus 6. Then we isolate all of the x to the left side and all of the constants to the right side. So that becomes 3x minus 2x is equal to 3 plus 6. So 3x minus 2x is x. 3 plus 6 is 9. So x is equal to 9. Let's now solve the equation 9 to the power of x squared is equal to 3 to the power of x plus 3. Let's write both 9 and 3 be written using 3 as the base. So that becomes 3 squared times to the power of x squared is equal to 3 to the power of x plus 3. Using power property for exponents, that becomes 3 to the power of 2x squared is equal to 3 to the power of x plus 3. Then, using one-to-one property of exponential functions, that becomes 2x squared is equal to x plus 3. Then we are going to transpose x and 3 to the left side. So that becomes 2x squared minus x minus 3 is equal to 0. As you have noticed, this becomes a quadratic equation. We are now going to factor this one. So this becomes 2x minus 3 multiplied by x plus 1, which is equal to 0. Then, we are going to solve for x. So, 2x minus 3 is equal to 0, or x plus 1 is equal to 0. So, x is equal to 3 over 2, or x is equal to negative 1. Property of exponential inequalities. If b is greater than 1, then the exponential function y is equal to b to the power of x is increasing for all x. This means that b to the power of x is less than b to the power of y if and only if x is less than y. If 0 is less than b is less than 1, then the exponential function y is equal to b to the power of x is decreasing for all x. This means that b to the power of x is greater than b to the power of y if and only if x is less than y. Note: you should be careful in solving exponential inequalities such as b to the power of m is less than b to the power of n. The resulting direction of the inequality m is less than n or m is greater than n is based on whether the base b is greater than 1 or less than 1. Let's now solve the inequality 3 to the power of x is less than 9 to the power of x minus 2. In this case, both 9 and 3 can be written using 3 as the base. So this becomes 3 to the power of x is less than 3 squared raised to the power of x minus 2. Then, using power property of exponents, this becomes 3 to the power of x is less than 3 to the power of 2 multiplied by x minus 2. Using distributive property, we distribute 2. So this becomes 3 to the power of x is less than 3 to the power of 2x minus 4. Since the base 3 is greater than 1, then this inequality is equivalent to x is less than 2x minus 4. So the direction of the inequality is retained. So 4 is less than 2x minus x. So 4 is less than x. Now, this is x is greater than 4. Thus, the solution is 4 positive infinity. Let's now solve another inequality. 1/2 to the power of x is less than 1/8. Let's now rewrite this as 1/2 to the power of x is less than 1/2 to the power of 3. Since the base, which is 1/2, is less than 1, then this inequality is equivalent to x is greater than 3. So, the answer is 3 to the positive infinity. Now, here are the references from Lago, Julie B.A., General Mathematics, Quarter 1, Module 4, Exponential Functions, 2020, DepEd, Northern Mindanao, and math.libretexts.org. Thank you very much for watching and listening. Please subscribe to Analyze Math.